Good morning, aspirant. So today we are going to start a new topic, that is analytical chemistry or practical chemistry. In this section, we will be covering first organic section, that is very much easy, and later on most difficult part, inorganic. So in organic part, analytical chemistry is basically when you go into the lab and your professor gives you, your professor or teacher gives you a sample, and he or she tells you to perform tests according to your convenience to get what functional group are present in that compound. So how to approach if any unknown organic compound is given, and how to analyze that, or how to determine the structure of the unknown compound. So we're going to look into that. In the whole in the analytical chemistry section, in last 3 years, I have read these 5 books, not five, one more book, 6 books, and these are the standard books. You should know the standard books from where you are reading. Okay, so first one is Advanced Practical Chemistry by S.C. Das. Second one, very much famous, Vogel's Qualitative and Quantitative Analysis. And these two are very much advanced book of analytical chemistry. One is by Skog and another is from Gary D. Christian. This is from Skog and this is from Gary D. Christian. These are very much advanced book on analytical chemistry. And another book I want to mention, it is very much a student-friendly book, I would say, because the language is very much easy. That is Nad Ghoshal Mohapatra. Nad Ghoshal Mohapatra is the name of the author. Okay, so Nad Ghoshal Mohapatra. These two books mostly I prefer for organic or for practical purposes, and other for theoretical purposes of the practical chemistry, theoretical background of practical chemistry. This Vogel's chemistry and these two books are very much famous and very much reliable worldwide. Okay, so intro is over. So let's start. Suppose you are in lab and our ultimate goal is to analyze a sample, analyze an organic sample. So we are going to study first organic practical or organic analytical. So what happens? Suppose this is your professor and he has given you one chemical compound, that is organic chemical compound, in a test tube. So this is one compound, and it is your now it's your job to find what is actually inside it. Okay, or at least the functional group present in this. Now to approach to the final structure or final groups present in this compound, there are 3 steps you should follow. First is preliminary method. Preliminary method. In this method, you cannot exactly tell what should be the present, but you can predict that this type of compound should present here. Second one is element test. I'm telling you why. In that organic compound, there may be functional group such as nitro, such as amino, such as carboxylic acid, such as OH. So there are very much functional group present. There may be halides. Okay. So there are 10, 20 number of functional groups are there. So in every functional group, there are some different tests. So one job is to random 1, 2, 3, 4. You perform tests one by one. So you have to perform 10 to 20 tests to get what functional groups are present there. But apart from that, there is a selective method. If you know the element present in the functional group, suppose you know in this element detection method, you get that particular sample contain nitrogen. Suppose in this method you are sure that the sample contain nitrogen, then you will perform only those tests where nitrogen is present, isn't it? So amino, nitro, diazo, this kind of tests you will perform. So your job is very much easy. Then you don't have to go through this all of this test. Okay. Detection technique has another name, another popular type of detection, that is Lassine test. And third one, when you know the element, then it is your job is easy. You are very much selective. There's with this element that functional groups are present, maybe present. So you are now selective. So now you will perform functional group test. Okay. So first preliminary method, it will give a basic idea. From here, you will not be sure. You will not be sure that which functional group should be present. But from here, you will sure about element, sure about element, sure about element. And here you will be sure about functional group. So in these 3 steps, you are going to perform the test in lab. Now, first one is preliminary method. Preliminary method. Don't look at this picture now. First, listen to my words. Suppose your particular compound, the particular compound you have, Suppose you are suppose you have taken some amount of sample from here. You have to complete the whole test from this sample only. So you should not waste the whole sample in one test. Okay, so you have to take a little amount of sample for every test. Now what you will do, you have made one solution of acid solution. You have made one basic solution in different test tube. Now some of the portion you added here and some of the portion you added here. Suppose your compound is dissolving in base. Now you can predict, and it is not dissolving in acid. So you can predict. We know acid dissolves in base, isn't it? So your compound is dissolving in base. That means your compound contains acid. So you will be performing test for acid groups, isn't it? Acid means it may be carboxylic acid, it may be sulfonic acid, it may be OH. Sometimes OH hydrogen is acidic. So this type of groups should present there. So from here, from this type of test, you will be getting a preliminary idea that what type of group should present. Okay, this preliminary method has another name. It is also called, as we are dissolving our chemical compound or solubilizing our chemical compound to different type of solutions, so it is called solubility method. Solubility solubility method. So I hope you have understood it. Now let's know step by step that how you are going to perform the test. First, you have unknown chemical compound. Add water. If you add water, if it is soluble, then the compound with single functional group, carbon atom less than 5, and it will be ionic. Water soluble, we know, like dissolves like dissolves like means same type of ionic system is dissolved in ionic solvent. Water is ionic solvent or polar solvent. So if it is soluble, that means the compound is ionic, and the compound with a single functional group. So that means it may be, and I'm telling you, these all predictions are not sure. Previously, I've written not sure, but a preliminary idea. You will be sure about the method when you will be applying method 2 and 3. This is to just clarify. Finally, the functional group you are having, this observation will clarify there. Okay, it will help you to make decision that okay, this functional group is aligned with my observation. Okay, so adding water will give you this conclusion: compound with a single functional group and carbon atom less than 5. Okay, if it is insoluble, that means water insoluble, then add NaOH. Then you have to add NaOH. If it is soluble in NaOH, that means NaOH means strong base. Sodium bicarbonate means weak base. HCl means strong acid. H2SO4 is weaker acid. That means I will not say rather weak, I would say strong. Okay, so NaOH, if it is uh, if you add strong base, that is NaOH, then it is soluble. If it is soluble, then you have to add one weak base, that is sodium bicarbonate. If it is soluble, then carboxylic acid and sulfonic acid should be present. I'm telling you why. Your compound is dissolving in strong base. Your compound is dissolving in weak base also. If your compound is dissolving both strong base and weak base, then definitely the compound should be very much acidic. Acidity should be very high. That's why it is dissolving in strong. If your acid is weak, then it will dissolve in strong base even. But it is if it is strong acid. So sorry, I'm making him confused. If the acid group is very much acidic, then it will be dissolving in both strong base and weak base. Now, if it is not soluble in weak base, so if strong base it is soluble, but weak base it is not soluble, that means the compound has acidity less, because it has less acidic. So strong base will able to dissolve that. Weak base will not able to dissolve that. So weak base will not able to dissolve those acids. Okay. So finally, what happens? Your conclusion is if it is dissolving in a strong base and it is dissolving in weak base both, then it is very much acidic. If it is dissolving in strong base but not dissolving in weak base, that means acidity is lower. Okay. So lower acidity means groups will be higher acidity means groups will be SO3H, CO3H. Lower acidity means groups will be OH or SH. Okay, phenols, thiophenols, this type of compounds. Now, if it is insoluble in NaOH, that means strong base, it is insoluble. It both the case, these are the both cases of strong base. soluble in a strong base. But if it is soluble in, it is not soluble in a strong base, then you have to add HCl. Then if you add HCl, that means strong acid. If it is soluble, then you can predict that it should be base. The compound should be strong base. Okay, strong base like aliphatic amine or primary aromatic amine. Now, if it is insoluble, then you have to add H2SO4, and um, if it is soluble, then there are weak basic systems like oxygen containing compounds, alkane, alkene, alkyne, etc. And if both are, if overall it is insoluble, then it should be alkanes, haloalkane, unreactivated aromatic compound, etc. So this chart is very, very much important for any practical understanding. This chart of solubility test is very, very much important because it will help you to predict that what type of compound should be there. When we were in lab, first what you used to do, first we used to take 7 8 test tubes. In one test tube, I used to put some water. In second test tube, some weak acid solution. Here some weak base solution. Here some strong acid solution. Here some strong base solution. Okay, and uh, I used to add this particular from this sample compound, this unknown sample. I used to put some pinch of that compound to this, and from this observation and with the table in mind, I used to predict that what type of compound should be there. As you know, this is the preliminary idea. So after this video, we will be discussing the next part of our discussion, that is element detection, that is Lassine test. Thank you.